So to recap what you did in class today, we're going to look at some of the vocabulary words again real quick. So periodic function is a function that repeats exactly in regular intervals. And one of the main things we're going to find when dealing with graphing these things is dealing with finding what the period is. So the period's the x distance it takes to complete one cycle. Frequency is the number of cycles completed over 2 pi. Finding the midline, that really helps us to identify where the graph kind of starts. And that is also known as the vertical shift. So how far up or down we're going to shift the function. Amplitude is the distance between the middle line and the max or the minimum. And my phase shifts, so how far left or right we are shifting the function. Now, just to go over our basic graphs, using the unit circle, we always want to find the values that are going to give me 0, 1, or -1, because those are the easiest to graph. All the other values on the unit circle give us bad fractions, so gross decimals, which are hard to graph. So when I think about sine, I want to look at my 90-degree angles. So we would have 0, pi over 2, pi, 3 pi over 2, and 2 pi. So when I plug those values into my function, y equals sine of x, right? So sine of 0 would give me a y value of 0. Pi over 2 on the unit circle, that gives me a y value of 1. Pi, back to 0. 3 pi over 2 is -1, and then 2 pi, back to 0. So graphically, I know that I'm going to only go up to 1 and down to -1. And we're going to go by my pi over 2's, right? So pi over 2, pi, 3 pi over 2, 2 pi. So 0, 0, pi over 2, 1, pi, 0, 3 pi over 2, -1, and then 2 pi is back at 0. So I get this shape, my wave. Now, it's important to note that that's only one period, okay? After I continue going past 2 pi, so I go around my unit circle again, it starts repeating. And that's why this is a periodic function, because it repeats constantly as I keep going. So if I were to add another pi over 2, that would put me at 5 pi over 2. And that would bring me back up to 1. 3 pi would bring me back to 0. And on it would go, right? Now, it's also important, remember, going clockwise gives me negative rotation. So I can also go in the negative direction. So negative pi over 2 would bring me down. And then this would continue in the negative direction as well. Now let's do the same thing with cosine. Again, I want those 90-degree angles. So 0, pi over 2, pi, 3 pi over 2, 2 pi. Plugging 0 into my cosine function. So cosine of 0 would give me a y value of 1. Plugging in pi over 2 would give me 0. Plugging in pi would give me -1. 3 pi over 2, 0. 2 pi, +1. So again, it maxes out at 1, bottoms out at -1. And again, we're moving by pi over 2's. That's my interval, or my increment that I'm moving through my unit circle. So pi over 2, pi, 3 pi over 2, 2 pi. This time I'm at 0, 1, so it starts up top. Pi over 2, 0, pi, -1, 3 pi over 2, 0, and 2 pi, 1. So I get this shape. And again, it's periodic, so as I continue going around my unit circle, it's going to start repeating itself. So if I went another pi over 2, that would put me at 0, and you just kind of follow the pattern. 3 pi, -1, it just keeps repeating itself. And again, too, this also can go negative. And it would continue in that direction as well. Now, just to kind of give a visual of all those terms we've talked about. So here is my amplitude. Okay, my midline is the middle line, right? It almost looks like it kind of splits the graph in half, right? So that's the midline. Here is representation of one period. And then we're going to talk about the interval and how that kind of helps us to graph these things. The interval, or the increment in which we move, would be my quarter period, right? So we're going to call that my interval. Kind of the steps I take to get those nice points to plot. So the general equations we're going to be dealing with look like those right there. So y equals a sine b times x minus c plus d. Now, these behave almost exactly like what we did at the beginning of the year with our transformations, right? So the big thing, remember, so this is where c is always the opposite. Okay, so whatever is given inside the parentheses, right, c is the opposite sign of that. My amplitude I get from my a value, and it's always the absolute value, right? My amplitude is always positive. My frequency, we find the frequency by doing 1 over the period. And my period we're going to find by doing 2 pi over b. So if I think about 1 over my period to find the frequency, that would really be b over 2 pi. Now my phase shifts, left or right, that comes from my c value. And again, c is always the opposite, right? And my vertical shift, my up and down, that comes from my d value. So your b value, that gives me my stretching and compressing. And we'll talk more about b values next time. We'll talk about negatives and how we handle those. We will do some stretching and compressing today as well. But first, let's just talk about finding all of the information. So with problems like these, it always kind of helps to label what everything is. So my a value is in front, that's 4. B value, if there's no number there, there's really a 1. C is the opposite of what's shown, so positive pi over 4. And then D is at the end, so that's positive 2. So my amplitude, absolute value of 4 is just 4, right? Always positive. And we're going to find our period first. So 2 pi over b, 2 pi over 1, which is just 2 pi. My phase shift comes from my c value, and that's positive pi over 4. So I'm going to go right pi over 4. Vertical shift is 2. That's going to move me up. Now, my frequency is 1 over my period, so my frequency would be 1 over 2 pi. Now, remember, your vertical shift is also represented by your midline. Okay. Looking at number 2, A is -2, B is 3. There is no C value, so C is 0, and then D is -1. So my amplitude is the absolute value of -2, so positive 2. Period is 2 pi over b. Now, if you can always simplify your fractions, make sure you do so. In this case, we can't. So my frequency would be the reciprocal of that, so 3 over 2 pi. Phase shift, there isn't one, right? 0. And my vertical shift or midline, -1, so that's going to move me down. Just like we did with our normal functions, right? When I'm given something that looks like this on the inside, I need to factor that 2 out. That 2 has to be separated. It has to look exactly like this on the inside if there is a b value. Okay, so I would factor out the 2. So dividing everything by 2 would leave me with x plus pi over 2 on the inside. So my a value would be 1, b would be 2, c would be negative pi over 2, and then there isn't a d value. So amplitude, positive 1. Period, 2 pi over b, which would just be pi. So then my frequency would be 1 over pi, like the reciprocal. Phase shift of negative pi over 2, so that's going to move me left, and then my vertical shift is 0. So that's just identifying the different pieces. Now we're going to put it all together and graph these things. So the steps for graphing, it's not always going to be laid out like this, okay? And sometimes it'll be laid out in different orders. And generally speaking, when we're graphing, it's just going to be, here's your trig function, graph it. So to help you kind of make sure you get all of your information to make graphing easier, we have this little kind of acronym here. So you can use MAPI or VAPI, depending on how you identify your midline or vertical shift. But first thing we're going to find is my midline, then the amplitude, then my phase shift, period, and the last one is my interval. So the interval we haven't really talked about yet. In order to find the interval of sine and cosine graphs, you take your period and divide it by 4. Okay, so if I think about my basic graph here, right, here is my first period, 2 pi, right? So my interval, I would take my period and divide it by 4, which would be pi over 2s. So that's why we move by pi over 2s on the x-axis, because that's what gives me my intervals for my nice points, 2, 3, 4, okay? So once we find the midline and the phase shift, that is what's going to help us to mark our starting point. And what we need to remember is our basics about sine graphs and cosine graphs. So sine graphs always start on the midline, right? And for cosine, we always start whatever our amplitude is above the midline, okay? So let's look at an actual graph here and put it all together. So using our acronym, right? So MAPPI. I always like to put a little H with the first P, so I remember that that's the phase shift. Identify your A, B, C, and D. So A is 3, B is 2, C is 0, D is 0. So my midline, my vertical shift, 0, okay? Amplitude, 3. Phase shift goes with your C value, which is 0, so we're not moving left or right. Period, 2 pi over B, which would be pi. And then my interval, I divide my period by 4. So setting up a graph. Midline still 0, okay, so that's just my x-axis. And it has an amplitude of 3, so that means my maximum and my minimum are going to be at 3 and negative 3 respectively. So 1, 2, 3, 1, 2, 3. And this is cosine. I'm not phase shifting anywhere, so it's going to look very, very similar to my normal cosine graph. It's just the numbers are a little different. So my interval is pi over 4. So pi over 4, 2 pi over 4, which would be pi over 2, 3 pi over 4, 4 pi over 4, which would be pi. So there's my full period, right? So cosine starts at the top, and then I just kind of do my pattern. So then we would be at 0, -3, 0, 3. And here would be one period of my graph. Now you could continue, right? Just to show you, right? 5 pi over 4. And then you could keep going in both directions, right? But for now, we're just going to focus on graphing one period, all right? So let's look at a little bit more challenging problem. So again, the acronym, M-A-P with a little h, P-I. A is 2, B is 1/2, C is nothing, D is -1. So my midline, or my vertical shift, right? -1, so it's going down. Amplitude is 2. No phase shift again, right? Because C is 0. Period is going to be 2 pi over B. So that would give me 4 pi. And then my interval, take your period and divide it by 4, which gives me pi's. So I'm moving by pi's. So, setting up the graph. All right, normally we would start at the x-axis, right? But my midline is moving down 1. So my midline is going to be at -1. So there's my new midline. Now my amplitude is 2. So that means that I'm going to go down 2 for my minimum and up 2 for my maximum. So that's going to put me down at -3 and +1. Phase shift is 0. And I'm moving by pi's. So pi, 2 pi, 3 pi, 4 pi. And it's sine. So it's going to start on the midline. No phase shift, so it's still on the y-axis. Up 2, back to 0, down 2 to -3 to 0. And I would get this guy. I always like to include little arrows just to remind us that it does continue, right? It keeps going. Got 2 more graphs. Look at a few more little things here. So, Mappy. A is 1, B is 1, C is -pi/2, D is +1. So my midline, my vertical shift, we're going up 1. Amplitude, +1. Now this time I do have a phase shift. Whoa. My phase shift is -pi/2. So we're going left, pi/2. Period, 2 pi over B. So that would just be 2 pi, and then my interval, divide that by 4. So establish the midline, right? Instead of being on the x-axis, we're going up to 1. So there would be my midline. And my phase shift, we're moving left pi/2. So instead of starting here, like we normally would with sine, like on the midline, we're shifting everything left by pi/2. So that would put me at -pi/2. And that's going to be my starting dot. So we can go ahead and put that point. Okay, so whatever the midline and your phase shift is, that kind of determines our starting point. And I'm moving by my interval pi/2. So pi/2 to the right would be 0, +pi/2, 2 pi/2, which would be pi, And then one more, right? 1, 2, 3, 4 would put me at 3 pi over 2. Now I just got to figure out my amplitude, and I can kind of just work my pattern. So amplitude is 1. So here's 1. That means I'm going up to 2, and then to 0, right? So following my pattern for sine, zero, and then there would be my graph. All right, last one. And this kind of incorporates a little bit of everything. So A is 5, B is 2, C is negative pi, and D is negative 4. So start with the midline, my vertical shift. We're going down 4. Amplitude, A is positive 5. My phase shift, we're going, C would be positive pi, right? C is always the opposite. So we're going to the right. Period, 2 pi over b, so that would be pi, and then divide that by 4 to get my interval. So this one has a pretty big amplitude, and we're shifting down. So when you're constructing a graph by hand, you want to take those things into account when you're setting up your axes. So I know this thing's going to be down 4, and it's going to go down 5 more, so it's going to be pretty far down on the negative, right? So I'm going to build my XY axis to kind of help me with that. So establishing the midline, we're going to go down to negative 4. That's terrible. Hold on. So here's negative 4. Now my amplitude's 5, so that means it's got to go up 5 from my midline and down 5 from my midline. So up 5 would put me at positive 1. Down 5 would put me down at negative 9. Now my phase shift, we're going right pi, and we're moving by pi over 4s. So we would have pi about here. And I'm going to put my starting dot, and it's sine, so it's the phase shift in the midline. So that's where my starting dot goes. And then I'm going to add pi over 4s from there. 5 pi over 4, 6 pi over 4, which would be 3 pi over 2, 7 pi over 4, and then 8 pi over 4, which would be 2 pi. And then follow the pattern. So up to positive 1, back down to the midline, down to negative 9, and back to the midline. And then draw your graph. And that's it.